Hello, welcome back and ready to do some logarithms. Uh,
Hi.
it's
Woo.
red day. We're all wearing our red and we got our red shoes on and all that
I'm
stuff.
still barefoot.
So what?
I said I'm still barefoot.
Yeah, you're barefoot. Well, my shoes aren't actually on, but so I want to look at a weird graph at the beginning of this lesson, if you don't mind, or a weird equation. X equals 2 to the y. This isn't normal for us. I mean, I know in the last lesson we were graphing things in the calculator. We might get to that eventually, but I want to try to make some some informed choices for this graph. And I'm going to start with a really easy one, and then Miss Young's going to have to pick one because I'm going to do the heavy lifting today. I'm going to make an XY key chart in the old school vein here. And so I'm going to start with X being 2. And if X is 2, then I get that by having 2 to the first power. So really Y is going to be 1, right? So.
No, Mr. Bobby, I wonder why you don't just start with Y.
I don't know, because I didn't want to be cute, but okay, if you want to start with Y, then you can.
Yeah.
You were going to try. I was going to try to trick you, but you didn't fall for my trick.
Oh,
So go ahead. So you
okay.
you do you.
We can go the other direction.
You do whatever makes you feel pretty. Oh, by the way, I guess I should plot that point, shouldn't I?
Yes. Yes,
so that
you should.
would be this point right here. Okay, so you do you.
So because it looks like Y is the input in this case, I don't have my annotation thing, so I'm grabbing it. There we go. I maybe would not do what Mr. Bobby did, which is like try to see when X is this, what is Y? I might actually do like when Y is 0. So I would actually start on the Y side and move to the X side, which is backwards from what we would traditionally do. And then I would say, okay, 2 to the 0. My dogs are coming in, sorry. 2 to the 0 is 1. So that would give me the point 1, 0.
Okay, so you want me to plot that for you?
Sure.
All right, so we're going to have another dot right there.
Yep.
Okay.
And then I might put in 2 for Y, which would be 2 to the second power, which would be 4. You can see my husband here in the background washing his hands because he was just outside.
Okay.
And then Y to the, 2, let's see, 2 to the third power. That would be 8. I'm a little worried though that at this point I'm gonna go off the screen and I haven't gone very far to the left. So what if I put in 0, right?
Yeah. Well, you put in 0 for Y.
I put in 0 for Y. What if I want
negative number for Y?
Okay, I'll try a negative number for Y.
A negative 1.
So like -1. 2 to the -1 power. What's 2 to the -1 power?
Well, let me go over here, help you out here. 2 to the -1. We talked about that in the last. When there's negative, I got to drop it down, right? So that's going to be 1 over 2 to the first power, or 1/2. Yeah.
So, okay. So now I have to graph the point 1/2, -1.
Oh, no. Now I got to do that. Why do like, I'm going to put it right there and say, be done with it. Okay.
Okay. So maybe I'll do that one more time. Like, what would happen if I had -2 in the Y spot?
Oh, my goodness. All right. Well, that's still going to be negative. So it's going to be 1. This one's going to give me 1 over 2 squared.
Yeah.
Which is what? 1/4?
1/4. So now you got to graph the point 1/4 -2.
You know,
but I'm not moving very far left. How do I get over that? How do I get over here in quadrants 2 or 3?
I don't know, but I don't know how to graph. Like, I'm going to try it right there.
Okay.
All right, but, well, I mean, you're picking Y's. You're picking all the Y's, and you ain't getting no negatives for the X's. So you're picking
so maybe I should pick a negative X?
But,
okay, so I'm going to put a -2 in the X. How do I get a X value that's -2?
Let me go over here and say -2 equals 2 to the Y. I don't know. Because I'm going to have 2 times itself a whole bunch of times, and that's always going to be positive, right? If that exponent is positive. And you already showed me that if it's negative, it's going to give me a fraction. I got, like, positive numbers times itself ain't going to be negative. This one, no way going to work for me.
So I can't have any negatives here?
I can't get over there in the second and third quadrant.
So do you feel like maybe we have a pattern of points then?
I do feel like it's like, I gotta, and I'm afraid to, I don't want you to do no more negatives because I don't want to deal with no more fractions, but you could, like.
Maybe I'll do -3.
You did -3.
And then I would do 4 times 2 in the denominator, and that would give me 1/8.
Okay, so I don't want you to, but it's going to be like way down here. I got to make it really close to the axis, but like there, negative.
Well, I think it's 1/8.
Oh yeah, I'm sorry.
And 3 down.
Right there. No, it's yeah. I'm sorry. My bad.
And so I'm just going to get like 1/8, 1/16, 1/32, 1/64.
And I can't get that close to the x-axis. I ain't going to do it no more. I'm done. I can't.
So it sounds like it's getting closer and closer to 0, but not getting there.
So yeah, that sounds familiar.
That does sound familiar.
Oops, well,
you just erased all of our points.
The wrong thing. Let me be. All right. I was trying to be cute and I ended up not being. Well, I'm always cute, but so.
I hope y'all noticed that Mr. Bobby just shaved his hair right off.
I'm not going to the barber. All right. I don't need to. So, all right. So, I mean, aside from the fact that I can't draw, I'm guessing it looks like that.
It looks pretty good to me.
All right. And if we go to our friendly neighborhood calculator, which I don't have open, so I don't have my mouse tool, that's what it looks like. Okay. In fact, I can even like move the graph and it comes out pretty close to what I had drawn. Okay. So, okay. Weird graph. I don't know why we're doing this.
I don't know why we're doing this either.
But it was sure kind of fun.
It looks like we switched x and y from y equals 2 to the x from the last video, though.
Yeah, it does kind of look familiar. That graph kind of looks familiar, but like not. It's like something, but not something. It's like, all right. So
what did we call it when we switch x and y?
I don't know. Oh,
do you remember what it's called? We switch x and y.
I think I do. Oh yeah, it's this thing.
Oh, it's the inverse. Yeah.
Oh, I love how we actually like. We like aren't this stupid. We just play stupid. We just play stupid in these videos because.
I mean, I'm not this stupid. I'm.
Yeah, it's all right. So if I were gonna do y equals 2 to the x, and then I would get. This is all well and good. Like nothing new here. All right.
We just graphed this, so we now know what the inverse of y equals 2 to the x looks like.
I know what it looks like, and I could have probably done it by, and all we did was switch it's the exponential 2 to the x, but reflected over the line y equals x. And we talked about that 2 lessons ago.
Yeah.
I don't know how to solve this for y. Yeah, I don't know how to solve this for y.
Yeah, so how do you get an exponent out of the exponent?
Yeah, I mean, like, I need something that tells me, hey, if you have this number, or this is the exponent you need.
Yeah. Or just like, hi, I need to get rid of a base. Can I get rid of a base? Anybody know how to get rid of a base?
Can't divide by 2.
Can't divide by 2. I mean, you can, but it'll just be like x over 2 equals 2 to the y over 2.
Yeah, I mean, it ain't going to help. So, like, we don't know how to solve, like, mathematicians, there's no add, subtract, multiply, divide,
no exponent,
nothing that's going to solve this, okay? So what we need is a new operation, and that's where math comes into play. Sometimes when we have to come up with a new process, and that new process is something called a logarithm. And the logarithm is really just the exponent. When we say the logarithm, we're trying to find the exponent we need on A. So I was trying to figure out what exponent would I need on 2 to get 8, or what exponent would I need on 2 to get 16, and so on. And the way I was trying to do it actually was kind of building towards a logarithm.
Sorry, my bad. I was thinking inverses in my head. I was like, I can just map backwards. Watch me.
Yeah, and so I was actually trying to do it the hard way of doing the logarithm, but you can't, I don't know that we're always going to be able to do Miss Young's process. And it leads us to a logarithm. So anyway, sometimes, we think a lot alike and sometimes we think differently, but I think that's actually a good thing because sometimes you may like the way I explain it and other times you may like the way Miss Young explains it, even though I'm better looking. So, all right. So
we can ask my husband. You think Mr. Bobby's better looking than me?
We don't want to get into this debate, bro. All right.
Looney Tunes shirt?
No, he's not wearing Looney Tunes today.
I'm wearing a corgi shirt. Imagine that. My Patronus is a corgi. So
He's wearing a corgi shirt.
imagine that. And a Harry Potter and a corgi shirt all in one. I mean, like, you can't get any nerdier than that.
That's the absolute truth. Okay, so back to
So
what
anyway,
we were.
let's talk about a logarithm. What a logarithm is, it is the exponent. We want to solve for the exponent. So when I think about this problem, the example I have here, log base 3 of 9 is equal to 2 because I know 3 to the second power is 9, okay? So now this is going to require, a little bit of powers. You may have like a powers chart or something. I know that was like real popular at Lakeside and like the algebra classes. And we probably have one posted on our Google Classroom too.
We should anyway.
We should. Yeah,
If we don't, be like, hey, in a video you said you'd post this and you didn't.
I don't now. I do. Yeah, I make a note, mental note, because we're still making the course right now. But anyway, I would have done that. I would have had that there. I know what I'm doing. I'm not totally stupid. Okay, so what my brain is telling, I know I need a number here. Okay, except I needed a pen first. So here's kind of how, if you have to do this by hand and you're not really sure, this is going to equal something. I don't know what that something is yet. Okay, so I'm looking for 2 to the something equal to 16. What do I have to put in that little box as something?
Ready?
In this case,
2 times 2 is 4, times 2 is 8, times 2 is 16.
So I don't want a question mark in there. I want a 4 in there.
A 4.
And if there's a 4 in there,
then the value of the log is 4.
so then this isn't a question mark, it's actually 4. Okay, now do you have to write this down? Do you have to write this down? What do you do?
I mean,
you put on your fingers like Miss Young did and get away with it?
I would say that if this were an open response question and I wanted full credit, I would find a way to write down my thinking.
Yeah, I'd write down something, but so it's also important that we're able to convert through these. So we'll talk more about this in a minute. So, all right, let's kind of think about the next one. 36, whatever is in the subscript, I'm going to put a little box here just because I like a box, equals to 6.
So it's got to get smaller.
All right.
It's negative. It's for sure negative because it got to get smaller.
It's for sure, for show negative.
For show negative.
All right. Well.
But -1 would be 1/36.
Yeah, that's way too small. If I put -1 in there, so it ain't for show negative.
Okay, so if it's, well, 36 to the 0 is 1. That's
we're getting
small.
closer though.
Yeah.
All right, well, what about 1? Oh, wait, no.
That'd be 36. So
Yeah.
somewhere between 0 and 1. Is that what we've decided now?
Okay.
Because 0 power was 36. Was 1, and the first power was 36.
Okay. Well, okay, so let's
just go halfway in the middle.
Okay, 1/2. So 36 to the 1/2. I don't know what 36 to the 1/2 is.
Ooh, we better remember 36 to the 1/2. Algebra 2 skills coming in hot.
Yeah, you never have to remember that when you have a fractional exponent, it's a root or a root. Okay. And what's the square root of 36?
6.
Hey, we looked into it. Good thing I did that, huh? Okay. And I should have known early on, back in my brain, I was seeing this. I know the square root of 36 is equal to 6. So how do I write the square root of something as an exponent? Then it would still have to remember something that Miss Young mentioned about the roots, the relation between radicals and exponents. Okay, so this guy here, he is 1/2. I know the next one already because we kind of argued through it in terms of 36. So, well, how did what Miss Young and I just said a minute ago relate to log base 7 of 1?
So remember your question here is 7 to what power, because you're always looking for that exponent, is going to give you 1.
Are you not seeing my writing? Like you wrote right on top of me.
I know I did. Your writing was in my way, so I just wrote on top of it.
Well, that was rude.
I'm staying in the column.
You just hush. All right, so 7 to the 0, and that box, just round that box off for me and we'll be good to go. Because any non-zero number to the 0 power is 1. 0 to the 0 is also undefined because it's kind of like division by 0. Okay, so that equals 0. All right, I don't like this last one because 8 is 8. 8 is 8. I don't need no exponent. Why do I need an exponent?
Well, it's got to have a value.
I don't.
So 8 to the what power is 8?
I don't need it. 8 is 8.
We need an exponent because
You're
that's
all
what
8 up.
log is.
You're all 8 up. 8 is 8. I don't need no exponent. But what I had to have an exponent. What could I put in there to not be so offensive? 1. All right. Silly Mr. Bobby.
So much arguing.
I know. Just move on. They're like, couldn't you two just do the lesson and stop being stupid? So nope, we can't.
No. We are not capable of these things.
Nope. All right. This is huge right here. Big, big, important deal. Like, if you want to learn something in this lesson, and if it was so important, I'd just let it stay on the screen.
You'd think that he'd have these arrows figured out by this point.
But so excited by my...
It's fine. We're just like 20 videos in.
I know. Okay. Right there. This guy right here. I think this is pretty big. Now, Miss Young's probably going to like draw you some loops and garbage or whatever.
Do you just call it garbage?
I don't know what you're gonna do, but I have, you're the log loop queen, aren't you?
I'm a visual learner, Mr. Bobby, and I like visual methods to get to an answer.
Okay, so visualize it for him, baby. Go for it. Do your thing.
So we're gonna convert. So if you're in log form, the base in the log is going to match the base in the exponential form. Now remember, the base is the number that has the exponent on it in exponential form. And yes, it's all about the base. And then the base in the logarithm is the little tiny number, the little subscript number. And remember, a log is always equal to an exponent. And so there's our exponent, y. And then that's going to give you that input value. And so this is a loop. I'm sure that you've learned it from one of your math teachers before, where you can go base to the equal sign and then back to the inside of the logarithm. You can do the same thing with this. You just want to make sure that when you do that, you're doing that with a highlighter. That's terrible. Yes, so, okay, we'll go this direction. So log to exponential, start with a base, like 2. Raise it to the 5th power. And that's going to give you 32. 2 to the 5th equals 32.
So the one below it, I'm going to get a to the third 3.2 equals to 15.
Yup.
All right, that works. Now, what about going the other way? What about if I have to go from because we did the problems out of order. What about going from exponential to logarithm?
So I'm in exponential. I know I need to write the word log. And I know that the base in the exponential form is going to be the base in the logarithm. And I know the log equals the exponent. So it's going to be equal to 2. So that means the 25 has to go in the inside.
Does that match up? Can we get back to where we started if we log loop that baby?
So 5 to the 2nd power equals 25.
I think it works. All right.
And you can do this. You can do the loop when you're in exponential form. You just have to go away from the exponent. So like if I grab a different color here, I could say log base 5 of 25 equals 2. So I can do the loop that way. You start at the base and end at the exponent. But I think too much looping is confusing.
Yeah. So if I did what you did a previous problem, I start with the base of the exponential as the subscript of my logarithm. So it's log e or log or whatever. And then the 28 is, no, the x is my exponent, right?
Yeah, it's got to be equal to the
exponent. That is equals, the logarithm equals the exponent. So the x has got to be over there. So the 28 goes there.
Yeah.
Okay.
And then you can check it. E to the x power is equal to 28.
All right, so we're able to go back and forth, and we need this. We're going to use this a lot in later sections, okay? So be able to go from one to the other, from the other to the one, okay? Back and forth, back and forth. And this is the inverse of the exponential. Remember, I keep telling you, things come in pairs in math. So, I mean, like, we didn't even have to wait very long for this partner to show up, okay?
Yeah.
It comes up pretty, and they're both.
And he says this is the exponent. Do you have 2 to the x on the next slide, or should we do that real quick?
You want to do 2 to the x?
So we were here, right? We were at 2 to the y is equal to x. Is this where we got stuck in that problem? We can go any further?
Right.
Or did, actually, let me put that in the right order.
You want me to go back to the slide that
we don't have to, I can do this right here.
Okay.
So we were at x equals 2 to the y, and we were like, how in the world do we get the y out of the exponent so that I could say y equals? Well, at this point, we could go to a logarithm. We could say, okay, what if I write log base what, Mr. Bobby?
2, because that's
base 2. What does it have to equal?
It has to equal the exponent.
Okay, so the exponent's y. And so the only thing left here is to put the x inside the logarithm. And there you go, guys. We've solved for y when y was in an exponent.
And that's the purpose of a logarithm, to solve for the exponent. And that's its main purpose for being. There's a reason I have a screwdriver in my garage, because it allows me to turn screws and screw them in and out. I have a hammer because it allows me to pound nails or pull nails out of a piece of wood. Logarithms exist to allow me to solve for an exponent. And we are going to need that in this chapter. Okay? And I got to get back to pink. I was writing in yellow. That just feels wrong.
I wrote in pink.
You don't get to write in pink.
I did.
Don't you do it.
I already did it.
And don't you do it. Now, I wrote log E a little while ago, and that was really weird for me. Like, I wrote this, okay, in the second one down here, and it took everything I had not to go ahead and do it as we do in real math. There's 2 logarithms that we use so often in math. Log base 10 and log base e are used so often that they get the shortcuts. You know, like when we write the square root, we don't put the 2 in the square root. When we write mx plus b, we don't put 1 on the exponent of x, which is why I was confused about 8 to the first power equals 1 or 8 to the first power equals 8. These 2 are used so often that when there's no subscript, there is an implied or an understood 10. And when we have log base e, we just call this natural log, or log au naturel. In other words, it's a log without bark. Da-dum-bum. Get it? No. It's a naked log? No? Okay. No naked logs? All right. These are so...
Their bark.
You don't want to see their bark? Their bark is worse than their bite?
I said logs. Oh, dear. I said logs need their bark.
Yes, they do. All right. So anyway, I'm such a dork. What can I say? When we use our calculator, and I don't remember what numbers, if you notice here above, there's ln or natural log there, and log above. It's actually on the 80th or on the Inspire, when you press this button, it will give you the template. So if I go control, and I don't remember what numbers I had, I'm just going to make up numbers. I could put a 10 there, but if I leave that blank, and put 1,000 in there, it will give me 3 because it actually inputs the 10 automatically for me, and it's understood or implied to be 10. Okay. And if I do control natural log, and then I can do like 345, and it gives me the number. Now, I don't think I actually did the ones that were actually on the slides. I know I didn't for a fact.
So just so we're clear about what that means, because you're like, what the heck, where are these numbers coming from? E is 2.718, blah, 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 blah. So we're saying that 2.718 raised to the 5.8435. Now, obviously, we're not going to get a perfect number here because this is a rounded number. He could have gone up and stolen that decimal.
Yeah, like I could have gone up here and gotten this number.
Right.
But I don't want to type in all the numbers. And I know.
Well, I mean, you could have done E and then, yeah.
Yeah, I know. I would do that for you, for their benefit. I could do E, and then while I'm in that box, if I scroll back through my history to that number, it will import that decimal for me, and actually even more, because the calculator keeps like 25 decimals or something. It keeps way more decimals than it can even display. And when I hit enter now, it faces over it. It gives me back 345.
Yeah.
Okay. And the same thing, and I don't need to do this necessarily, but I guess I do. 10 to the third, what will I get here? I'll get our faces are in the way again. We'll get the 1,000 back.
Yeah.
Okay. Now, I didn't do the numbers that were in the lesson, but it's a typing exercise. You can jam puppies out.
Absolutely. All right. Although we might want to type that natural log of -3 in.
Oh, yeah, we probably should. That's a good one. Yeah, I want to do that one. All right, so I'm going to do control natural log -3. I'm just going to be plunking away here. Wah! I broke my calculator. Mr. Bobby, my calculator. Please do not email me when you get an error message until you have read it and tried to figure out what. So let me read this non-real calculation. For example, if the software is in real setting, the square root of -1 is invalid. To allow complex calculations, change the real or complex mode. All right, that didn't help me too much. Well, why can't I, wait, the square root of -1, that means something to me. I can't take the square root of a negative, right?
True.
So is this telling me I can't take the square root or take the logarithm of a negative?
Well, what power of E would give you back a negative?
No, we had this discussion at the beginning, didn't we? Yeah, I can't take the logarithm of a negative number. Okay.
Yeah.
You know, like I knew that, and Miss Young knew it, but folks, like, you know, the people who actually make money are the people who think through their own problems. So maybe, you know, try to read and figure things out. But, you know, nobody's listening to me. I'm just some old dude with a shaved head. I can't believe you made fun of my head.
I didn't make fun of your head. You're making fun of your head. I just pointed it out.
Yeah, I can't draw very well, but I tried, and Miss Young laughed at my graph.
I did, because you could have just copy and pasted from the calculator.
I know, but I wanted to be lazy and not have to. I didn't want to put just a graph screen in there. I wanted it to be there forever. And so the graph looks something like that. And we could put these in the calculator, but this is just like the increasing, decreasing for the exponential we saw in the last chapter.
Yeah.
Everything for the exponential kind of translates into the logarithm. They go back and forth, but they're opposites, okay?
Yeah, because you've done that reflecting over the y equals x. Yeah,
we've done this reflecting. I don't know who does the diagonal. I mean,
I don't.
Your things is this way, Beyonce's is this way, but who does diagonal? I don't know. Anyway, if a is greater than 0, if that base is greater than, 1, if the base is greater than 1, the graph is increasing. If the base is between 0 and 1, the graph is decreasing. Instead of having a y-intercept, we now have an x-intercept because we're switching x and y. It was 0, 1 for the exponential, now it's 1, 0 because this is the inverse. If the x-axis was the asymptote for the exponential, now it's vertical, it's y equals, again, switching x and y. The domain and ranges are exactly the same, but switched. No surprise there, and they are still 1 to 1. Okay? Moving on.
So much good information.
Oh my goodness, yes. All right, so everything is sort of the same, except, and we're going to do a couple transformations and then look at an application and you'll be ready to go. So we know we have to decide whether the graph is increasing or decreasing based on the base of the logarithm. Since that base is 1/2 for this first for h of x, I'm pretty sure this one's decreasing. All right. What else do I know about this graph? Why did you circle that +4? What's that tell me?
That's different.
That's different.
Not just x. So on the inside of the logarithm, directly to x.
Okay.
So the opposite of what you think. Left 4.
Left 4. All right. We can look at, I've already prepared, and Miss Young makes me do this ahead of time, so I do all this extra work, and she just, eats pizza.
That's true. I ate pizza before this video.
Yeah, she really did. It was
scrumptious.
Okay, so the black graphs, just like in the last lesson, I had I made the black graph be the parent function. There's the graph of the logarithm 1/2. It's decay or decreasing. Keep using the wrong word. And then it's moved left 4 spots. So where is this point right here now?
At -3, 0.
-3, 0, because it was at 1, 0. So I want to make sure that you get this. This intercept is at -3, 0. Okay. What's the equation of the asymptote? Again, that's not really part of the equation. What was it before? It was y equals a number. Now it's going up and down. It's.
Oh wait, I need to be going backwards.
This would be x is at -4. When you're adding to this, so the number that you're adding or subtracting, or the shift horizontally is your asymptote in the logarithm. Okay. All right, let's go back to the other example. Now, I made it a little harder because I'm mean. This one you might want to rewrite. Okay. I'm going to write -3 log 6 of x plus 5. So okay, now we got the -3, the negative, the 3, the 6, and the 5. This one tells me it is increasing, right?
Yeah.
So that means my graph is going to look like that, right? But what's the negative do? That's the upside down. That's the Stranger Things, right?
Yeah, that's your Stranger Things flip.
Okay. Please don't write that when you get to college.
They're gonna go to like the next math class and be like, "This really isn't called the Stranger Things flip."
This is a vertical reflection. Oh my gosh. I like Stranger. Do you watch Stranger Things?
Oh yeah, I think it's great.
You don't remember the upside down then? You just have bad memory, I guess.
What? I'm the one that said the upside down.
What about the 3? What's the 3 do? That's a
vertical stretch.
Okay, vertical stretch. What about the 5 on the end?
That's on the outside of the function, so it's going to go up 5.
Okay, so that's going to be up 5. All right.
He's trying to go too fast. That's what happens.
So I'm going to clear all this out because I've got it already graphed for you. And it's right here. Let's see if we are correct. I'm going to need some help making sense of this graph.
Yep. So before, it's decreasing now, but before it was, you remember it was flipped. And so, it's upside down. So it was increasing. Because it was flipped, it's now decreasing.
So maybe we ought to do it in stages. because I have the first, like I have the original graph right here in black, but then I have the finished product, and maybe I'm not seeing it all at once. So how about we do this?
Okay, I think they're good. I think that they'll understand this. Like it was increasing. That's the base.
Yeah.
Now it's flipped. That's the negative.
Oops, I gotta put the log button.
You're gonna do it anyways, aren't
I'm
you?
gonna do it anyway. I don't care about you. I'm
Okay.
in charge of the computer right now. Not 3, it should be 6, huh? Now I'm regretting my choices. But that helps me, just in case you're having a little trouble with it. It's a reflection. This green graph is a reflection of the black graph, but it's also been stretched a little bit, then scooted up 5. So I maybe should have put that in there and brought it back, but whatever. So, okay. Sorry for that little diversion for a few seconds. So, all right. So
You know, we could have done all that with sliders on Desmos and just slid it to where it needed to go.
I could have built sliders too, yeah. All right. So learning curve for a fry cook at McDonald's. For the learning the percentage of the job. So like whenever you go to a job the very first day, you don't know what you're doing, but during the first day, you learn a whole lot. And then the next day, you're going to learn a little bit more, but not everything you're ever going to need to know, and so on. Okay. So it's modeled by the equation fry of X, because he's a fry cook.
Because he's
And I actually should have done fry of T. He's a fry cook. Okay. And I don't know.
fry of C.
That should be that. Forget that. Where that should
Whoa.
that should say fry of. That should say fry of X.
Ruh-roh.
I'll fix that. Okay. Is the percent of the job learned, and X is the number of days worked. So how much does the person learn after 1 day, after 11 days, and 101 days? Okay. How long do you think it takes to learn to be a fry cook?
I mean, I don't know. I've never done that job before. So let's find out. Let's go to the calculator. We're going to type in 1, 10, 101.
Yep. So let me clear this baby out here and go to make a new page here.
I don't remember the equation now.
I do. It was 15 plus 45 log of whatever, right? Because it was,
Okay. Of X, yeah.
yeah, or was other 45 and 15. So I have my 45 and 15 reversed.
So you start with 45% of the knowledge that you need before you ever.
It's not a hard job. Well, at the end of the first day, you have 45 at the end of your first day.
Yeah, okay.
All right?
45%.
So you learn 45% of what it takes to be a fry cook at the end of the first day. Okay.
Okay.
Not so bad. I mean, that's a hard day, but you know, your hands are probably burnt. You got some blisters or whatever.
That's true. That's true.
So now let's learn some more. So he works a couple weeks. And I said 11 days. So after 11 days of working,
He only knows 60% of what he needs to know after 11 days.
yeah, I
Oh
mean,
dear.
it's a hard job.
This,
Okay.
this boy or girl.
Yeah, this person is learning. I mean, he knows like 60% of what he needs to
He
know.
only learned 15% more. Okay.
Yeah, no, that's like, this is how the job works. All right.
Is
And
it?
I said 101, right? For the next one.
101 days. Okay.
So I'm going to put a 0 in here and see how much he's learned.
My God, this poor person.
You know what?
They have worked here for 101 days and they only know 70. If I'm their manager, I might fire them.
But you know what? This is what it takes. This is the learning curve for anything. How long have you been teaching, Miss Young?
Like 17 years.
All right. And how many? So that's like 17 times like a million days.
Wow. I'm old.
So you've been teaching 17 years, right? So 17, how long is a school day or school year? It's 178, right? So you have worked 3,000 days as a teacher.
Okay.
Do you know everything you need to know about being a teacher?
No. Absolutely not.
Okay.
I wish I did though.
I've worked with all the time.
So you're saying this is the learning curve for anything?
Kind of any job, yeah.
Okay, so put 3,026 days into this,
Yeah,
and
so
let's
like
see what percentage I know.
What percentage of, like, if this were applicable to teaching? So Miss Young only knows 3,026 or 3,000. So, hey, you know 97% about what you need to know for being a teacher.
Mr. Bobby's been teaching longer than me. Let's see how much more he knows than me.
Okay, I've been teaching for this. I just finished year 21. So oh my gosh, I don't even want to think about that. And I bet I can retire. I hope I can retire. Come on, 100%. Dang it. I really don't know much more than you.
Not much more.
Not much more. I've been teaching for 4 years longer. You mean in 4 years I've only learned 1%?
That's unfortunate for you.
Yeah, I know. It's pretty crummy.
So how long is it going to take to get to 100%?
That's what I want to know. So I'm going to just go straight to a graph and do that, okay? So let's add a graph to this. And it was 45 plus 15 log of x. All right. Well, that didn't help me.
That's not pretty.
Not very helpful at all. But let's think about the graph here.
We want to go to 100.
I want to at least go up to 100, right? I'm probably going to go a little higher because I'm going to see it go. All right. Well, that helps a little bit. But remember, what kind of numbers were you and I talking about? We're talking about,
we were at like almost 4,000 and not there yet.
Dude, don't, no. Let's be nice, all right? So, did I just call you dude?
You did.
I'm going to put 5,000 out there. All right.
We need to graph the line y equals 100. Can we do that?
I do need a point of reference, 100 here. Yeah. I wonder if those two cross.
Ooh, I think they do, actually.
Maybe they do. Maybe there's a point out here where I don't have to learn anymore. We're not going to quit working. So menu, analyze graph, intersection. Let's see. I want this guy. I want to go out here. Did I get it? Oh, yeah. Looks
so
like
you were really almost there, Mr. Bobby. You are almost
retire soon, yeah. It takes about 4,000 days. We're actually more than 4,000.
Oh, yeah. Closer to 5,000 days.
Yeah, well, 4,600, because I got to move the decimal point 3 to the right. It takes 4,640 something days to learn a job, or for this fry cook to learn his job.
Let me tell you something. If it takes 30 years to learn how to be a fry cook, we are all in trouble.
Okay, you just went there and made it personal. You know, that was my first job in high school. I worked at like Arby's and stuff, dude.
My first job was at a Dairy Queen.
Okay.
I made ice cream cones.
Oh, wow. I bet you got it all over your hands too, because they always like flop over and stuff. I was terrible.
I made perfect ice cream cones, thank you, with the Dairy Queen curl on the top.
Yeah. All right, there's your practice problems. Happy.
Bye, guys.
Bye,
Thanks for joining us again.